Okay, to find the temperature of the star, you find the peak wavelength, and you put it through a calculation called the Wien's law, and you can get the temperature of the star. And then once you get the temperature, you can get the flux, which is the amount of energy per meter squared coming from the sun. And once you get the flux, you can find the luminosity, because luminosity is just how much energy per second coming from the sun. And once you figure out the luminosity of the star, you can find the mass, because there's a relationship between mass and luminosity. It's generally the mass of the star or the mass of the sun to the 3.5 power equals their luminosities over each other, the ratio of their luminosities. So after that, the composition is easily, because the lines in the spectrum represent atoms or molecules, depending on the star. The hotter the star, it tends to be more hydrogen and helium. The lower end, towards the red end of the spectrum, it tends to be, you can actually get molecules, because the star is so doesn't have as much energy. Okay, there's the Zeeman effect, which the lines actually split up due to two different lines in a magnetic field. One will spin a little bit higher and a little bit lower than the average of the two, and that'll give you the magnetic field. Also, metallicity is the amount of metals in a star, and in astronomy, anything higher than helium is a metal. So that's easy to figure out once you find the composition. The mass of a planet around it is, if you see it go redshift from red to blue on regular period, you can figure out the period of the star, the period of the orbit of the planet, and you can determine the mass from that. The composition of its atmosphere, if the planet passes between you and the star and the starlight comes through, you can see the spectrum of the atmosphere, and you can take away the spectrum of the star. Magnitude is associated with luminosity. There's two different magnitudes. There's a visual magnitude and there's an absolute magnitude. Absolute is when it's at 10 parsecs away from you, which is 32.6 light years, and visual magnitude is how it appears. And you also can get the distance from that through the distance modulus formula. There's probably a few that I missed, but generally you can get a lot out of the light of a star. And goodbye and thank you, and hopefully somebody found this important.